Hello, Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG. We're going to do another video today for those who are brand new to amateur radio, because there are so many things that we just get completely used to that, you know, we sometimes forget new hams really don't know what it is that we're talking about. And what we're going to talk about today is coax. More formally known as coaxial cable, coax or coaxial cable. Now, this is a special kind of cable designed to move RF, radio frequencies, from one place to another, like from an antenna to your radio, or from the output of your radio to the antenna. And the thing is that, you know, normal house wire is built for the national grid, which oscillates at 60 hertz, or 60 times per second. We're here talking about things that oscillate many millions of times per second. And the problem is, if you use house wire, weird things happen. It doesn't work right. There's some cases when you can do it, but hams don't do that anymore. We use coax. Now, there are many different types of coax, and we're going to go through some of them here. What we're going to look at today is different types of coaxial cable, okay? And then we're going to look at different types of connectors, including looking at the connector that, if you all handhelds these days have removable antennas, and so you can put something in here and connect it to an antenna on the roof of your car or on your house. Okay, so let's start with coaxial cable. This is my standard demonstration cable, and I'm going to show you what goes on here. Okay, if you look at this cable, this is LMR 400 made by Times Microwave. They are an American company that makes premium cables. This LMR 400 coaxial cable by Times Microwave Systems. Now, when you buy this, you can buy near clones from various people. Lots of Chinese companies will put 400 in their name to make you think that that's this. I once worked with a ham who was very proud to have purchased LMR 400 cable, and I helped him put a connector on it. He couldn't put a connector on it. So I went over with my connector kit. It was Chinese cable. And the way this cable is made, I'll show you here. You've got two coverings to keep the RF inside the cable. You've got this braid, okay? Then it is wrapped in aluminum foil, okay? And even though this is copper, it's covered, it's tinned copper, and there isn't a problem with it as long as you keep it dry in terms of corrosion. Then you'll find in here, you see this white stuff? You can see it end on here. It surrounds the inner conductor. Now, the inner conductor, in this case, is a piece of aluminum wire covered in copper, plated in copper. Now, according to the skin effect in RF, RF goes through wires much differently than your ordinary wall AC or your station DC. It tends to travel on the skin, so it will travel on the outside of this wire and on the inside of this shield. Now, this is important. There are different types of insulating material. They're usually called dielectrics. A dielectric is something that you can put it between electrical plates, like in a capacitor. The dielectric has properties that cause what's going on to shift. In this case, this right here is a modern dielectric, which has a velocity factor of maybe 0.88, but we can just start with this to see how coaxial cables are made. They're all made the same way. By the way, this is around an aluminum wire. The aluminum wire is there for strength and to give it a stability. The RF is actually carried in the copper or in the outer parts of the aluminum. And the reason they can put aluminum in here is to make this cable very light, because it's used like in cell towers for very long runs. Now, the problem that I had with the guy's Coax from China is that the aluminum in it was extremely brittle and kept breaking. Every time I'd get the everything set up for the connector, it would break. Now, why is it called coaxial? This shield right here makes up a tube that runs the length. The center of that tube is the same as the center of this wire. We call each of these coaxial, meaning they share the same axis, okay, or center, share the same axis. This stuff was invented originally by Bell Labs for transferring telephone calls very long distances. And the reason that they found this to work was, first of all, you could put many telephone signals on one coax. And they used to make the coax out of copper tubing and little spacers inside. So this is LMR 400. All coaxial cables have an outer conductor. In this case, it's made of two pieces, which is the aluminum tape and the copper. Right here, this is all tinned, so you can solder this to something very easily, and you can solder a connector, or in better yet, is use the LMR 400 tools sold by Times Microwave, and you can put a crimp connector on here very easily and very quickly. I will warn you that those connectors are expensive, about $25, $26 a piece, and then you've got to pay for the tool, so you've got some additional. But if you want to do a first-class coax job, you're going to do that. Now, this cable can be used for high frequencies and very high frequencies, okay? Now, there are thinner cables, and I want to show you this one. Okay, so there are thinner cables. Now, this one right here is made of a kind of coax called RG8X. Now, Times Microwave does have an equivalent of this, which is LMR 240. But this one right here is made by Belden, and it gives a 9288, which is RG8X. RG8X. Now, the RG8X is my favorite cable. It will handle up to 1,000 watts. The amount of power it can take is a function of the dielectric and how big the cable is. And this right here is my favorite cable. It's very floppy, so you can use it for jumpers. This right here is pretty stiff. This one right here is the LMR 400, just stiff. You can get LMR 400 that's more flexible if you want. Okay, now this type of cable contains connectors, and these connectors look like really weird things, okay? These connectors, along with the kinds of things that it connects to, this, are called UHF connectors. That term is one that traces its way all the way back to World War II, when they thought that something like 10 meters was an ultra-high frequency. Well, it wasn't and isn't. And UHF connectors is a bad name for these because not a lot of people know that that's what they're collectively called. This connector right here is called an SO-239. SO-239. And your radio, if your HF radio has one of these on the back, probably if it's a full power radio. These connectors are called PL259s. Now, it is common practice that you put the male connector, the PL259, on both ends. If you have to hook another piece of cable in, you use what's called a barrel connector. You can buy these easily. And this comes right over this. Okay, and you screw the outer cover on this. Now note, finger tight, no more. And then you've got the plug where you can put in another PL259. So, common use is you make your coax cables with PL259s on both ends, and if you have to connect some together, you use these little barrel connectors. Okay, now there are other types of connectors. There are other types of cable. This happens to be RG58. I prefer RG8X myself. It's a little bit thicker. Notice that if you solder these on yourself, this little insert right here is different depending on the cable size here. And there's a different one for RG8X and RG58. I've gone to the point now where I almost always use crimp connectors. This is an example of the LMR 400 crimp connector. And this is the center. Now note that this does not go back on it like this does here, where we can kind of see what's going on. So you have to twist it on just by putting that part on right there, and it will draw it on. These are excellent connectors, and they're close to being watertight. I should mention that these connectors, which are so common in radio, are not watertight. When you put these with barrel connectors, if they're outdoors, you need to wrap something waterproof around it. I'll show you that in a little bit. Okay, now other connectors. See, we've got here a little box. This happens to be a signal sampler for use with a spectrum analyzer. It has the SO239 connectors on it, and this goes from the radio to a dummy load. Then the sample comes off here with a different kind of connector. This connector is called a BNC, and it's named after two people who invented it, and yes, it was the second connector that they invented. So it was the B, and then the NC are the initials of the people at Bell Labs who invented it. The nice thing about these, you can get crimp connectors for this too. I'm always was afraid of these connectors because QRP users use these a lot more than they use these. This is a crimp connector with a little heat shrink tubing over it. I've tested it, it works, and it is crimp, both this and this. Okay, these are little BNC connectors. Usually they go on right there, like that. There's a little peg right there, and this goes on over the peg and then turns. And it's got a spring in it, and it holds it in size. Most instrumentation, like oscilloscopes and so on, use these BNC connectors. They're very useful and very easy to put on. You don't have to reach up somewhere and turn something a million times. It's just a quarter turn and off, or a quarter turn and on. Okay? And then the other end of this happens to be connected to a BNC connector also. This is a piece of cable that I use with my oscilloscope and a signal generator and spectrum analyzer. And they work just fine. Okay? Now, when you do this, it is possible to get adapters. Very easy to get on Amazon. And so you want to mail a BNC connector, okay, to a female SO239, okay, and then you can attach one of your PL259s to that. Okay, now I find these very useful because my station is set up with these PL259s going to the antennas. So if I want to use, say, a QRP radio that uses the BNC connectors, I can use one of these adapters. I keep a bunch in my adapter box, so I've always got them. Now let's look at another type of connector that you'll see occasionally. This right here is what's called an N connector. Now this happens to be an adapter from N connector to BNC because I use BNC for my instrumentation, and the spectrum analyzer had these N connectors on it. In Europe, these are extremely common. In fact, the radios in Europe come with N connectors on the back. They're uncommon in this country. Some really into it hams swear by them. You'll have a tiny fraction of a dB less loss if you use the N connector rather than a PL259. Now let's talk about one other connector you're going to see a lot. This is a TID radio right here that's in for review. And right in the top right there, you can see that this is a male SMA connector. Okay, this is designed for very high frequency use, which of course this is a VHF radio, and it's not very much power, so they use the SMA connector. Now this is a female right here. It just has the little hole in the middle, and the threads are on the outside and thread into the threads on the radio. Now you say, maybe I don't want to use this antenna. You can buy these adapters, and I would recommend the kind of adapter that has a little bit of coax in it. Coax takes a twist, so you can't twist one end without twisting the other. So I'm going to put this into here. Notice that this is twisting with it, okay? Now, I've got this, and it is connected to an SO239. So now I can take, like the antenna that's a mag mount on my roof, which will have a PL259, put it on here. All this is 50 ohms. And now you connect it, and you don't put a lot of strain on that connector. Now there are little adapter things here. Here's one that's a male. Okay, and the radios, there's no standard. Some are male, some are female, and so you got male going to female, or you might have female going to male. You want to double check these because they are incompatible with each other. But this is an example of an adapter. Here is an adapter that's female that would take it to a BNC connector. Okay, so you can get these adapters for anything, but this tends to lessen the strain on the adapter, which is mounted right straight to the circuit board in here, and you don't want that to get broken. And then this can connect to your on-the-roof mag-mount antenna. All the mag-mount antennas come with PL259s. Now what's also interesting is that the radios like this one right here, which is a mobile radio mounted in a base configuration, it has an SO239 on the back, and so you need a PL259. Go figure, okay? Some of the older radios came with BNC connections here, which were very handy to take on and off. Here's a connector you will rarely see in amateur radio anymore, is the phono connector. The old Heathkit equipment, if you have some, used the phono connector. And I had a heck of a time with that when I was trying to get my coax first up. I was a brand new ham. I had this Heathkit equipment, and so I needed this for one other thing. MPD Digital is one place where you can have custom cables made, and I had this one made there. It's only 2 feet, and it connects some really odd stuff. Okay, what we've done is we've looked at different kinds of cables, coax cable. Now, yes, there are other kinds of cables, but the coax cables are really cool because they keep all the RF inside of them, and they won't crosstalk to another coax cable that's right next to it. So you can bring all your cables in together. So the coax cables very commonly are used in ham radio to move RF from one place to another. And my favorite cable for HF or power under, say, 500 or 800 watts would be RG8X. There is another kind of cable called RG213 that is the same size as the LMR 400. Okay, it's much less expensive. It has the braid inside, the copper braid on the for the outside conductor, but none of that fancy aluminum tape. Also, you can use standard PL259 connectors on the RG213. There are other cables used for moving RF very, very short distances. They're little tiny cables. All RF has a loss per foot that is frequency dependent. RG8X is not a good cable for VHF because it has a fairly high loss per foot. For like a 50-foot run up to an outside antenna, you might be better to bring the antenna down so that the coax doesn't lose so much. I think I've given you a number of good options here for cables. So that's coax cable. There's nothing magic about it. There's no length of cable that you need to avoid, contrary to some people what they're saying. You can run it anywhere. I would recommend that where the cable comes into the house, you have a ground rod and you put a lightning arrestor on that ground rod and run the cable through it. This thing, I've got two different ends, but that's PL259 on each side. But lightning arrestors, whole nother topic. So there you have it. You've learned about coax cable. And a lot of times hams like to buy coax cable with both ends already attached. Now, I want to warn you that the coax cable you need is much longer than what you might think it needs, because you're going to go out of your shack down to the ground to the lightning arrestor and then up to the antenna. What you can do if you want, route a piece of string the way you're going to route your coax cable and then measure the length of that string. You will be amazed. It'll be about twice as long as you think it will be. If you do end up getting a coax cable that's a little too short, you can put the connectors on both ends, use a barrel connector. There is a tiny impedance bump there, but not too bad. I've done that for years. Okay, so there you have it. I would say you can get coax from DX Engineering, Ham Radio Outlet, MPD Digital, all kinds of places sell coax cable. Also, you can go, like in Grand Junction, there's a store that handles commercial repeaters and so on. And they keep this stuff in 500-foot rolls, and they're usually willing to sell you the amount that you need for your project. So, and you can get the connectors all on Amazon. The best name in connectors is Amphenol. They make connectors that are the standard. You can get much less expensive connectors, but if you're going to put in, say, an antenna system that you're not going to touch for a while, go ahead and get the better connectors. So, or get coax with connectors already on it. The drawback of connectors already on the cable is you need to punch a larger hole in your wall to get the cable through. Make sure you caulk that up so the mice don't get in. So, until we next meet, 73.